Hello everyone, my name is Neelaj Ghanate. In this video, we are going to dive into one of the most important topics of DevOps and cloud world, that is the complete Kubernetes architecture. If you have ever been working with Docker and wondering how to scale your containerized application, or if you're very much curious to know what exactly Kubernetes does under the hood, this video is for you. If you ever felt Kubernetes architecture as very complex and confusing, I promise you by the end of this video, you will have a complete understanding of every core component of this architecture. Now, before we understand what exactly Kubernetes is, let's understand the world without Kubernetes. Imagine you have an application that suddenly becomes very popular. Now, your user base keeps growing. At this time, you cannot afford any kind of downtime. Now, as more and more users start using your application, you need more servers to handle the traffic. However, without automation, someone has to manually spin up those servers where there is a human intervention. What if your application crashes at 3 a.m. in the morning? In that case, someone from your team has to wake up, SSH into that server and restart that application. What if the entire application crashes? In that case, again, someone from your team has to move all your workloads from that unhealthy server to a healthy server to keep the application running and get it online. So again, here you need human intervention in order to do this process. However, if you are using Kubernetes, everything is done automatically. That's the power of Kubernetes. What exactly is it? It is a open source container orchestration solution. It's a container orchestration platform where it automatically scales up your applications when the traffic is high and scales down when the traffic is down. Now, it also replaces unhealthy servers to healthy ones, restarts your containers, and keep all your applications running at all times without any downtime. So you have no panic calls and no downtime. That's the power of Kubernetes. Today, Kubernetes is one of the most in-demand skills in the market. Before we understand the complete architecture of Kubernetes, it's very important to understand the basic component of the Kubernetes, that is a pod. Now, what is a pod? A pod is an abstraction layer over your containers. It is a wrapper around your containers. Instead of running containers directly like we used to do in the Docker, we run them inside these pods now. So these are much more powerful than containers. Why? A pod can have a multiple containers inside them. Now, these are the disposable units that Kubernetes can be created, destroyed, and can be recreated. That is why they are referred as very, very powerful. It's very much important that we understand the basics of these pods. Now, pods are ephemeral in nature. Why? Pods are ephemeral in nature. Now, what do you mean by ephemeral? They are short-lived. It means that these pods can be created, can be destroyed. That's why they are referred as ephemeral in nature. Now, as I told you, a pod can have a multiple containers. A pod with one containers is nothing but a single container, or a pod with one or more containers is nothing but a multi-container. Now, as a standard, most of the pods are single container pod. Like 90% of your real world pods are a single container pod. Now, when do we need a multi-container pod? Let's say you have your main application and that application needs to collect some logs or maybe to handle some security. We use these containers beside the main containers that shares everything inside the pod. That's nothing but a sidecar container. Now, so as I told you, pods are ephemeral and they are short-lived. Pod can have one or more containers inside them. They can be created, destroyed, and can be recreated by the Kubernetes. So now, what exactly inside the pod? As I told you again, I repeat myself, there are containers inside the pod. Now, these containers share same IP address, same network's namespace. and these pods can share the same volume, for data persistence, and they can also communicate. The containers inside the pod can communicate each other with local host, and you don't need any DNS, or there's no need of network hub. So that's why they are very much powerful. The containers inside the pod, they bond together and die together. Once the pod is down, all the containers inside it are gone. So that is what all about pod is. Now the question is, now who manages these pods? Where do these pods run? Who runs these pods? Who decides where to run, and who scales them up or scales them down? So pods don't make their decision on their own. It's the brain behind the scenes that runs this. So that's how Kubernetes architecture is designed. It is designed with some superpowers. We'll understand that later. Now it's time to understand the Kubernetes architecture. Kubernetes architecture is broadly classified into two major parts. One is control plane and the other one is worker nodes. Now, control plane is the brain or the decision maker of your Kubernetes cluster. It is also referred as master node. However, the word master node is deprecated, and even the Kubernetes documentation says it's a control plane. Now, what are worker nodes? Worker nodes are the nodes or the machines where your actual workloads run, where your applications run. That's what your pods run. Pods run on your worker nodes. That's why we understood pods before we understand the architecture. I hope you understand now. So let's see. Here we have a control plane and 3 worker nodes. A typical production grade cluster generally have 3 or more control planes and 3 or more worker nodes. And now let's understand how a request flows through every component of this Kubernetes cluster. Here we have a developer and he wants to interact with the Kubernetes cluster. Now, to interact with the Kubernetes cluster, we need a command line tool. That's nothing but kubectl or kubectl. So when a user runs a command, let's say he wants to create a pod on the cluster. Now, the kubectl command or the client that sends an HTTPS post request to the API server in the control plane node. Now, what is API server? API server is the heart of Kubernetes. So this is the only entry point for all your cluster operations. Every request for creating a resource, for example, let's say pod, now we are creating it. So it has to go through the API server. So API server is the only option where you can communicate and process your requests. So this is the only entry point, only gateway for your request to be processed. Now, when an API server receives a request from a kubectl client, it performs certain security checks. Now, as part of it, the first step is authentication. Now, what do you mean by authentication? It's nothing but it verifies the identity of the user making that request is genuine or not. Now, it just verifies the identity of the user. Now, once the identity is confirmed, it moves to the authorization stage. Now, what is authorization? Here, it checks whether the user or the identity is allowed to perform a requested action on the cluster based on certain rules. So, it usually checks the RBAC rules, or nothing but a role-based access control rules. Now, in case the user does not have any required permissions, the request is rejected then and there, and it sends a 403 forbidden error, and the process stops there. So after, let's say the request is authenticated and it's authorized, it passes through something known as admission controllers. Now, what are these? These are nothing but, I would say, some software plugins that intercepts the API requests and impose some additional checks on the request that is made. So now, once all checks are succeeded, now the API server need something to store its information. Now, here where
comes in the etcd server. Now, what is etcd? Etcd is the cluster's reliable key value store and a single source of truth for the entire cluster state. So what is it? It's a distributed key value pair. I would say, in a simple words, it's a database for your cluster to store your cluster state or to store your cluster's information. etcd stores everything about your cluster. It stores every pod that you created, every deployment, every configuration setting, or everything on your cluster is stored in the etcd. If etcd gets wiped, your cluster forgets everything. That's why it usually run on multiple nodes with backups. So, and one important thing here is to know that API server is the only component that communicates with the etcd server. No other component can communicate with the etcd server. Now, I would say, if the API server is the receptionist, etcd is the register where all the information is stored. So that's what etcd is. Only API server communicates directly with etcd, and when etcd confirms the write, the API server stores the desired store in the etcd. etcd stores the desired state of the cluster. Now, developer wants to create a pod. That's a desired state that's stored in the etcd cluster. I hope it is clear to you. Now, let's understand the other core component of the control plane, that is our control plane. Control manager. Now, what is a controller manager? I would say Kubernetes is powerful just because of this core component, that is controller manager. Now, everything that is automatic because of this controller manager. It constantly watches the API server for the state of the resources and make sure the actual state matches the desired state. That's what its job is. So this is basically made collection of many controllers, and these controllers maintain the desired state of the cluster. The controller's job is to maintain the desired state. It's always monitoring, always adjusting, and keeping the system stable without any manual intervention. Automation is the key word, I would say, for the controller manager. Whenever you see controller manager, you just remember automation. So it's a collection of controllers, and it maintains the desired state of the cluster. Now, we were talking about pods. Where do pods run? They run on the worker nodes, but pods don't make decision on their own. They need something. There is a brain behind it, as I told you, that has to be scheduled on the worker node. Now, here comes our scheduler. Now, at this point, we have a pods resource that exists in the database, but they have no node assigned. Am I right? So we store the desired state in the etcd. However, there is no node assigned to it. Now, the kubeset scheduler, as I told you, it also constantly watches the API server, specifically for a newly created pods that don't have a node assigned. So what it does, the scheduler's job is to identify the most suitable worker node to run the pod. Now, how it makes decision? It makes decisions so intelligently. It performs certain checks, like it says, it checks the nodes have a resource availability or not. It checks whether a node has enough CPU for the pod to run on, or memory. It checks other constraints like taints and tolerations, node selectors, affinity and anti-affinity rules, resource quotas and limits. All other checks it does, it filters out the nodes and schedule a most suitable worker node to run the pod. Now, it makes the intelligent decisions and tells the API server the pod should run on certain node. In this case, let's say it binds node 2 for the pod to run on. Now, where do this pod run? It runs on the worker nodes. Now, what is worker node? Worker node are the machines where your actual workloads run. So we have pods. If you see, it has a kubelet, it has Kube-proxy, and a container runtime. Now, let's understand every component of the worker node each. So now let's understand the kubelet. What is kubelet? Kubelet is an agent that runs on every worker node. You see, on 3 worker nodes, we have kubelet. We have the component kubelet on it. So it's an agent that runs on every worker node. It receives instructions from the API server and ensures that containers defined in the pod are running and healthy. It also always maintains the healthy states of the containers. At any point, if a container crashes, it restarts it. It manages its entire life cycle on that node and reports the status of the pod and the node back to the control plane every then and there. So if a pod crashes, it restarts it. Now, Kubernetes does not run containers directly, right? I told you they run them inside the pods. Now, what containers rely on? They rely on a container runtime. Now, if you see in the Docker, we run containers, and the containers runs with the help of container runtime. In Docker, we have something called Docker shim that runs the containers. Now, Kubelet tells the container runtime, start this container, and the runtime pulls the image from the container registry. So it pulls the image from container registry and runs it. That's what container runtime does. Now, as I told you earlier, Docker used to use something called Docker shim as its container runtime, but in modern Kubernetes, we have you have standardized container runtimes like container D, CRI-O. Docker was also the container runtime for Kubernetes long back. However, now it's in older versions, but now it's deprecated. So, but these runtimes follow certain standards, container runtime interface standards, they are referred as. This means Kubernetes does not care which runtime you use as long as it follows the CRI standard. It works. So if it is following CRI standards, that's container runtime interface standard, then it doesn't care about anything. It just runs. Now comes our Kube-proxy. Now what is Kube-proxy? What is its job? Now every pod in Kubernetes gets its own unique IP address. Every pod has unique IP address, but how does the traffic reach these pods now, and how do these pods communicate with each other? Now, this is handled by Kube-proxy. So all the networking in the cluster is handled by Kube-proxy. It allocates IP addresses to the pods. It enables pod-to-pod communication. Set up network rules using IP tables. It enables load balancing across your multiple pods for the easy communication. Everything about the networking is managed by Kube-proxy. You can think Kube-proxy as a network administrator on each node, making sure all communication is done smoothly. So these 3 components, one is Kubelet, Kube-proxy, and container runtime. Container runtime, they work together on every worker node to run all your applications. So what is a kubelet? It's an agent that runs on every node and maintains the healthy state of your containers. Now, what is container runtime? Container runtime is nothing but it ensures that containers are pulled from a container registry. It starts container. Kubelet tells the container runtime to start certain containers, and it does. Now, Kube-proxy, it handles everything, pod-to-pod communication, networking. It manages. It's a network administrator, I would say. Now, we are now left with one important component, that is a cloud control manager. Now, what is it? Now, Kubernetes can also run on cloud platforms. Now, what are those? We have AWS, we have Google, we have Azure, Microsoft's Azure. Now, every cloud provider has some Kubernetes service. That is, Amazon has EKS, Amazon EKS it is called as. and Microsoft as Azure AKS, Azure Kubernetes Services. Amazon EKS is Elastic Kubernetes Service. Google's GKE, Google Kubernetes Engine. Now, the Cloud Controller Manager is nothing but a bridge between the Kubernetes and the cloud provider. Now, what do you mean by that? So, Kubernetes itself does not understand cloud specific APIs. Now, here is the problem it solves. Let's say you're running Kubernetes on Amazon's EKS. You create a service of type load balancer. Now, Kubernetes needs to create the actual AWS Elastic load balancer for you. But the API server does not understand AWS, right? It does not understand AWS. So it does not know how to call the AWS APIs, to provision the load balancer or to configure, let's say, cloud storage. Now, this is where your cloud controller manager comes in. So it acts like a translator, I would say, taking your Kubernetes request and converting them into cloud provider specific actions. So that's what cloud controller manager does. It's a mediator between API server and a cloud provider, and it translates the cloud provider language for the API server and process its requests. If you're that's what the cloud controller manager does. So this component is not required if you're running on a bare metal servers. You don't need these components. But on cloud platforms, yes, this component is very much essential. I hope the entire Kubernetes architecture and all its components in the cluster is clear to you.